So, good morning once more. We are going to look at matrices. So, under matrices, before we do anything, we'll be looking at addition, subtraction. From there, I'll talk about multiplication, and that is the end. I don't want you to fail matrices. So, allow me to talk about matrices. What are the matrices? This is just an arrangement. So, definition. So, this is the arrangement. So, this arrangement of numbers, in rows and columns, this is columns, in a rectangular form, So the arrangement of numbers in rows and columns is what we are calling matrices. So what is a matrix? Just the arrangement of numbers. Now those numbers are not numbers, they are not mere numbers. They are called entries. So we are saying entries are numbers. Entries are numbers in a matrix. So entries are numbers in a matrix. So whatever is there, e.g., example, if they tell me examples, so we are going to look at examples. Imagine I've got K, got 3, 4, I've got N, I've got a matrix which looks like this: 0, 1, 3, 4, 3, 4. So these numbers are what we call entries. So far I've said this is the arrangement of numbers in rows and columns. So allow me to talk about now the order of the matrix. So the order of the matrix, when we talk about the order of the matrix, we just talk about the name of the matrix. Matrices have got names. So under the order of matrices, we are saying if these matrices have got names, we have got the rows. Allow me the general formula. If this is my matrix, it has got A, B, C, and D. These are what we call rows. Row 1, row 2, and this is column 1, column 2. So if they ask me to say state the order, to state the order of the matrix, how do we state the order of the matrix? We just say we start with rows. We have to start with rows by columns. So times in mathematics means by. So rows by columns, or you just say rows times column. That is what we are calling the state of the order of the matrix. So for example, this one you can see there are 2 rows, 1 column. There are 2 rows, 3 columns. So this is it. For example, I will now show you how to answer such question if they say state the order of the matrix. I hope you are enjoying Matthews. Please remember to share the link. Okay, Matthews, we continue now. This is how they will bring a question. They will tell you to say state the order of the following matrices. So if you look at these matrices, we have to name them. So if for A, for example, I've got P equals to, this is a matrix. You can see the types of brackets I'm using. We use these brackets, so it means how many columns? I've got one column. How many rows? Sorry, I've got one row, two columns. So it is 1 by 2. So if they ask me to say, what about B? K, matrix K, you agree with me that it has got how many rows? I'll start with the rows. There are 1, 2. There are 2 rows. How many columns? 1, 2. It is another 2. So it is a 2 by 2 matrix. C, if they say, Angel, find for me the L. State the order of this L. I'm telling you, just have to know that here, let me just answer it from here. You tell me that how many rows? 1, 2, 3. So this is 3. How many columns? 1, 2, 3. So this is a 3 by 3 what? Matrix. So I'm sure you have enjoyed. You cannot disappoint yourself if they ask you to find the order of the matrix. Thank you so much. We go to the next one. We'll continue. We are looking at now operations on matrices. With matrices, we do the addition and subtraction, multiplication. We don't divide. There is no division when it comes to matrices. Matthews, I'm saying there is no division for matrices. So don't say we will divide a matrix. No. But instead, we have got only addition and subtraction. So addition, subtraction, and the multiplication. Now, these two, addition and subtraction, they follow the same principle. You are going to see what will happen. They have got the same rules. So, for example, if they tell me that Angel find A plus B, the first matrix they have mentioned is the one I should write. Don't interchange. So this is my A plus, what is my B? My B is negative 3, 1, 0, 4. So you agree now I talked about entries. What is my first entry here is 3. Here my first entry is negative 3. So these are what we call entries. So corresponding entries, the first one should add the first one. The second one should add the second one. The fourth one like that. The third one like that. No need of you making it, swapping like 3 plus 0. No. These 3 you see should just work out with another 3. But always when you see a negative and a positive, the positive is killed. However, a negative. So it's the same as just saying 3 minus 3, not 3 plus minus. No. Because positive times negative is negative. So here it will be just a minus. So the answer I'm going to have here is 3 minus 3 is 0. 5 plus 1, it is 6. 4 plus 0, it is 4. 6 plus 4, it is a 10. So it means you have what? You have added. Corresponding what? Same corresponding entries. That's what you should consider. I'm saying that whenever they ask you to find the addition or the summation we are adding of matrices, the corresponding what? Entries. Now let's look at something here. I did it deliberately. Allow me, I'll start with your B. My B is negative 3. And of course it is a 1, it is a 0, it is a 4. So I have a situation like this plus A. So my A, it is a 3, it is a 5, it is a 4, it is a 6. So now what will happen is this. When you are asked such a question, rule number 1 is that corresponding side, this corresponding, it will correspond with a 3. Remember, this is a negative, this is a positive. The answer will be a 0. Because negative 3 plus 3, it is the opposite. It will have a 0. 1 plus 5, it will be a 6. 0 plus 4, it will be a 4. 4 plus 6, it will be a 10. You can see something, we can conclude something here. What is that which I can conclude? I can conclude something with addition. What is that which I have concluded? I've concluded that the following should be noted. The following should be noted. Not the following. I should conclude that number 1, A plus B is equal the same as B plus A. They are the same. Why? So our conclusion under addition of matrices is that matrices are commutative. So the law of matrices, we are saying matrices are commutative. Commutative, it means you can interchange them, but the answer will remain the same. You can interchange them, the answer will remain the same. For example, I'll put asterisk. For example, 3 plus 2, is it the same as 2 plus 3? If the answer is 5 here, even the other side is 5. For real numbers, addition, it is interchangeably. Equally, when it comes to what? To matrices, you can interchange matrices and you get the same answer when you are doing addition. Thank you so much. Allow me to move forward. We go to subtraction. We'll look at subtraction of matrices. So we continue with subtraction of matrices. I told you that they are very similar. The rules or the principle is the same. What we do in addition is what we do also in subtraction. For example, I've got this matrix. Let me just put it a general matrix. It is subtracting another one. Just giving you an example. It is subtracting another one, but here we go. They say Angel subtract this. If this is, for example, now I say, okay, imagine this is matrix A, this is matrix B. They are subtracting A minus B. You agree with me that this 5 minus 3, it will be a 2. 5 minus 3, the first entry should deal with the first entry, like addition. So here I'm going to have a 2. 4 minus 1, I'll get a 3. 3 minus 4, I'll get a negative 1. Remember, it is the bigger number coming from the smaller number. The answer is a negative. 2 minus 6 to be negative 4. So this is my answer. I want you to note something. Is it true that when also I subtract B minus A, am I going to get the same? Let's see. I'll start with 3 because that is my B. This is the matrix for B. I want to show you something. We are subtracting. How do we subtract? We are saying, are they the same? We are trying just to see if they will be the same. If they will be the same. So we start now. 3 minus 5, I'll get a negative 2. 1 minus 4, I'll get a negative 3. 4 minus 3, I'll get a positive 1. 6 minus 4 or 2, it will be a 4. You can see that this matrix, these two matrices are not the same. So what is our conclusion? Our conclusion is that with subtraction of matrices, that is our conclusion. If with the subtraction A minus B is not the same as B minus A, that is our conclusion. So Matthews, for matrices, never ever interchange them and expect to have the same answer. No. Even if you are in a hurry, you are doing your mathematics, by mistake you interchange them and say, let me just continue because it will be the same. No. For numbers, no. Look at even numbers. Asterisk, I'll put the numbers here. 3 minus 2. Is it the same as 2 minus 3? Here I'll get a positive, which is not the same as negative 1. I hope you have seen that even in numbers, you cannot interchange them to get the same answer. Thank you so much. I love you. We'll go now for multiplication, and this is our last segment for today.